Hi, I am Junaid Rahman from Pakistan. I would like to thank the 26th International Conference on Knowledge Base in Intelligent Information and Engineering System to accept this paper, an efficient smart streamlet management system using Internet of Things, with the collaboration of Aspandyar Khan, Javed Iqbal Bangash, Abdullah Khan, and et al. These are the paper outlines. I will discuss it one by one. Number 1. Introduction. Waste management is one of the genuine issues faced by our society. It is generally handled by the local municipal authority through some traditional approaches, but there are many limitations of these approaches. However, considerable number of research has been performed on solid waste management. Some of them are in next slide. Actually, this is the comparative study of our proposed system. These are the developed modules and their functionality. A paper titled A Real-Time Smart Dumpster Monitoring and Garbage Collection System. In this paper, the author developed a module having functionality of collecting waste level data, taking automatically decision on that data, and informing waste collector through SMS, and also provide visualization for the concerned authority. And paper 2, the author developed a module having only 3 functionality: collecting waste level data, data store and server, and visualization for the concerned authority. The model third is same like model 2, but having one extra functionality of taking automatically decision on data. Toward paper 4, the author developed a module for electronic waste management having the functionality of collecting waste level data, data store and server, taking automatically decision on that data in the form of informing waste collector through notification, and also provide visualization for the concerned authority. And the last, this is our proposed module having functionality same like module 4, but one extra functionality of that this proposed system is for liquid waste management, and all these modules are for solid waste management. Problem statement. According to our survey, there is no such efficient smart system for streamlet management, actually for liquid waste management. Therefore, this intelligent system is developed. Paper objective. The first objective of this paper is to design and develop an efficient smart streamlet management system using Internet of Things. The second objective is to evaluate the performance of the proposed system in terms of accuracy and threshold parameters. Proposed system. This is the overall architecture of our proposed system, in which the sensor kit collects data from streamlet and forward that data to cloud through internet and network interface, and automatically taking decision process is performed on that collected data in cloud in the form of mobile notification. Also, the concerned municipal authority can visualize the sensor collected data in form of graph entries. I will explain all these components one by one. Number 1. Sensor kit. The sensor kit consists of ultrasonic sensor HC-SR04, Node MCU microcontroller board, network interface ESP8266. The ESP8266 is actually a Wi-Fi module and power supply battery. The functionality of the sensor kit is the ultrasonic sensor measure waste level of the streamlet, and the microcontroller board forward that data to cloud server through network interface. The second component and third component is cloud and mobile notification. The ThinkSpeak cloud server is used which analyze the data in the form of forwarding notification to waste collector. A mobile notification is automatically forwarded to waste collector when the sensor collected data is matched with the cloud threshold value. This is the screenshot of mobile notification, and the waste collector need to be install IFTTT app on their smartphone to receive the notification. The fourth component is visualization for municipal authority. The concerned authority can visualize the current status of the streamlet through HTTP request from cloud like this. The graph actually represents the filling level of the streamlet, and the location show the deployed sensor kit location. Twelve result and analysis. A case study is conducted to evaluate the performance of the proposed system. For that purpose, 3 cases are conducted, which is actually practical experiments. In each case, a threshold value is defined in cloud for generating and forwarding of notification. During the experiment, we assume a container as a streamlet. Each case is evaluated through these equations: accuracy and threshold difference. In case 1, the threshold value for streamlet filling is set 71% in cloud, which means that the proposed system should be able to notify waste collector in real time when the streamlet is filled 71%, and also need to exactly show 71% in their corresponding cloud graph. But here the system generates notification on 70% of streamlet filling, and its corresponding cloud graph shows 71%. So there is 1% difference between the actual filling of the streamlet and its corresponding cloud graph. So the accuracy of the proposed system in case 1 is 98.59. In case 2, 81% threshold value is set in cloud. Here the system generates notification on 80% of streamlet filling is shown in the figure, and its corresponding cloud graph shows 81%, which is again 1% difference between the actual filling of the streamlet and its corresponding cloud graph. The proposed system achieved 98.76% accuracy in case 2. In last case, 86% threshold value is set in cloud, but here the system generates notification on 85% of streamlet filling, and its corresponding cloud graph shows 86%. So there is difference of 1% between the actual filling of the streamlet at end and its corresponding cloud graph, and the proposed system achieved accuracy of 98.84% in this case. This is the overall comparison of all 3 cases. The proposed system achieved best accuracy of 98.84% in case 3 when the threshold value is set 86% in cloud, and the difference between the actual filling of the streamlet and its corresponding cloud graph is constant and 1%, and it is tiny and may not cause the streamlet overfilling, and it can be overcome in future. This is conclusion and contribution. The implementation of this proposed intelligent system in the society can enhance the quality of life and can make opportunities for government and businessmen to invest money on such a project. The proposed system achieved best accuracy of 98.84% on 86% of threshold value in cloud. Again, the author would like to thank the organizer of this conference to accept this research. These are the references, and thanks to everyone.